Hey everyone, and welcome. Today, we are diving deep into the Internet of Things, or IoT. And I know, it's a huge buzzword that gets thrown around all the time. But forget the hype for a second. Think of it as the next massive step in how we live and work with the world around us, a world where everyday objects suddenly have a digital voice. So let's get into it.
Here's our game plan for today. We're going to start by looking at where this whole idea came from. Then we'll literally break down what makes a thing smart. After that, we'll figure out how all these things talk to each other. And then for the fun part, we'll see how you can actually build one yourself with something like an Arduino. And finally, we'll zoom way out to see the incredible future that IoT is building for all of us right now.
All right, first up, to really get what IoT is all about, you got to go back in time a little bit, to its ancestor, something called machine-to-machine communication, or M2M for short.
This, right here, is the core promise of IoT. It's all about answering simple questions like this one. It's about taking ordinary objects and giving them the smarts to understand their surroundings and then do something about it, all without you having to do a thing. This is the magic that takes us beyond just simple, dumb machines.
So what's the big difference between that old M2M stuff and today's IoT? Well, think of it this way. M2M was like a private one-to-one conversation, maybe an ATM talking directly to a bank server. It was super limited. IoT takes that idea and throws it onto the internet. Suddenly, you're not just connecting two machines, you're connecting everything through IP networks, adding layers of software, and letting tons of people access the data. That's the key takeaway. IoT isn't just machines talking to machines, it's a whole universe of smart devices working together.
Okay, so let's move on. Now we're going to pop the hood on one of these smart devices. What's actually inside? What are the essential parts that make a regular thing an IoT thing?
It all kicks off with sensing. This is literally how the device perceives the physical world. Just like we have eyes, ears, and a sense of touch, an IoT device has sensors. A temperature sensor feels how hot or cold it is. An ultrasonic sensor sees how far away something is. These are the digital senses of our device.
So the device has senses. Now what? Well, it needs to be able to do something with that information, right? That's where actuation comes in. If sensing gives the device its senses, actuation gives it its muscles. This is the part that takes action in the real world, like a motor spinning a fan, an LED turning on, or a smart lock bolting a door. It's where digital commands become physical actions. And what connects the senses to the muscles? The brain, of course. In IoT, this is the microcontroller. And for a lot of you B-Tech students out there, this part will look pretty familiar. We're talking about chips like the ATmega 328P, the heart of the Arduino Uno. This little powerhouse runs all the code, analyzes the data from the sensors, and tells the actuators exactly what to do. It's the command center for the whole operation.
So when you boil it all down, you get this super simple but incredibly powerful cycle. Sense, process, act. That's it. A sensor gathers info, the brain thinks about it, and an actuator does something about it. This three-step flow is the fundamental logic behind pretty much every single IoT device you can think of.
Okay, so we've got the thing part down. Now let's talk about the internet part of the Internet of Things. I mean, one smart device is cool, but a whole network of them? That's a revolution. So the big question is, how do they all talk to each other? Well, it's complicated. Right now, it's kind of like a digital Tower of Babel out there. You've got devices speaking Wi-Fi, others speaking Bluetooth, and then you have others speaking specialized languages, like Zigbee, which is great for low-power stuff in your smart home. This creates a huge challenge called heterogeneity. How can a smart light that only speaks Zigbee possibly understand a command from your phone, which is using Wi-Fi? The answer, the solution to this whole mess, is this word right here, interoperability. You could call it the holy grail of IoT. It's the dream of getting all these different devices running on all these different protocols to just work together, seamlessly, no restrictions. Achieving this is the absolute key to unlocking the true power of a connected world.
All right, enough theory. Let's get our hands dirty, shall we? For any of you looking to actually start building this stuff, the Arduino platform is one of the absolute best places to start. So let's take a quick look at how you can actually bring a thing to life.
Now, if you've ever touched C or C++, this is going to feel right at home. An Arduino program, which is called a sketch, has two main parts. You've got the setup function, which runs just one time when you power the board on, perfect for setting things up. And then you have the loop function, which, you guessed it, just runs over and over and over again, forever. This is where all the main action happens.
Okay, let's build something. A classic starter project, a distance sensor. We're going to use a super common sensor, the HCSR04. The goal is simple. Make it tell us how far away an object is. This is a perfect, simple way to see that sense, process, act cycle in action.
The physics behind this is actually really straightforward. The sensor shoots out a sound wave that we can't hear. We just need to time how long it takes for the echo of that sound to bounce back. Since we know the speed of sound, we can easily calculate the distance. And why do we divide by 2? Because the sound has to travel there and back, so we only need half of that total travel time. Simple.
And here's how that physics turns into actual code. We're not going to go line by line, but basically, these first few lines tell a sensor to send out a quick ultrasonic ping. Then this next line listens for the echo and measures how long it was gone. And finally, we just plug that duration right into our formula to calculate the distance. It's elegant, it's powerful, and it just works.
So, we've built one little smart device. That's cool, but what happens when you scale this idea up? When you connect not just one device, but millions or even billions of them across an entire city? Well, that's when things get truly mind-blowing. That's the future we're building.
I absolutely love this analogy. Think of a smart city as a living, breathing human body. The buildings and roads, that's the skeleton. The essential services, like hospitals and banks, those are the organs. The communication networks are the nervous system, carrying messages everywhere. And what are the sensory organs? The millions of IoT sensors spread across the city. And the brain that makes sense of it all? That's the software. The city becomes a single intelligent organism.
And this isn't science fiction. This connected organism is already changing, well, everything. In healthcare, wearable sensors are monitoring patients from their own homes. In agriculture, smart systems are saving massive amounts of water by only irrigating crops when they truly need it. Smart grids are making our energy use way more efficient. IoT isn't just one industry. It's a technology that's making every other industry smarter.
So, we've gone from a single tiny sensor all the way up to a massive, intelligent city. We've seen how IoT works and the absolutely incredible potential it holds. The tools to build this future are cheaper and more accessible than they have ever been. The world itself is becoming a platform. So the only real question left is, what are you going to build?